All right, welcome to this explainer. Today we're diving straight into the somewhat brutal reality of scaling generative AI applications. More importantly, we're going to talk about how to defend your budget. Look, if you're building with large language models today, you already know the incredible things they can do. But actually scaling them to thousands of users? Well, that is an entirely different beast.
So, let's kick this off with a bit of a chilling reality check. Read this quote. Most AI startups do not die from bad models, they die from bad unit economics. The companies that actually survive the jump from a cool prototype to full production, they fundamentally shift their mindset. They stop looking at an API call as just a normal function call and start treating it as a literal financial transaction. Because when you're operating at scale, that's exactly what it is.
Which brings us to Section 1, the AI Startup Death Trap. Let's look at what happens when the invoice actually arrives.
Imagine this. You build a beautifully functioning RAG chatbot. Your users absolutely love it. And then, bam, you get hit with this staggering number. 22.5 grand. This represents the monthly LLM cost alone for a totally unoptimized app with just 10,000 daily active users, making maybe 10 queries a day. And remember, that's before you've charged your customers a single dime and before you've even paid for your databases or infrastructure.
Let's actually break down the math here because it perfectly illustrates how fractions of a cent can cascade into an absolute nightmare. If you've got 10,000 users making 10 queries a day, and each query has 1,000 input tokens, so your system prompt plus the context, at $2.50 per million tokens, you're looking at $250 a day. Add 500 output tokens per response at $10 per million, that's another $500 a day. Multiply all of that by 30 days, and yeah, there's your $22,500 invoice.
But here is the truly brutal part of this whole equation. Between 40 to 60% of those queries you just paid top dollar for, they're near duplicates. Users are literally asking the exact same questions, just using slightly different words. You are paying full price over and over again for completely redundant computation.
All right, Section 2, Anatomy of an API Call, or as I like to call it, the silent killer.
So, where exactly is all this money going? Well, a massive chunk of it is going to the silent killer of your application, your system prompt. Think about it for a second. Your system prompt is identical across every single request, yet it gets billed every single time. A 1,500 token system prompt sent with 100,000 daily requests burns through over $11,000 a month. You're paying thousands of dollars for text that literally never changes. Ouch!
So how do we fix this? Let's move to Section 3, the 3 caches, and stop paying for redundant compute.
The big question is, how do we stop asking the model to think about things it's already thought about? Your absolute first line of defense is built-in provider caching. These give you massive, immediate discounts. Anthropic uses explicit markers to give you an insane 90% discount on cache hits. OpenAI takes a totally automatic approach. You don't even need to change your code, giving you 50% off matching prefixes. And Gemini offers around a 75% reduction. This layer alone can basically slash that system prompt cost we just talked about.
But here's the catch. Provider caching only handles identical prefixes. Semantic caching is your custom layer for the trickier stuff. Look at these two phrases. What is the return policy? And how do I return an item? Totally different words, but the exact same intent, right? A semantic cache embeds both queries, checks their cosine similarity, and, if they're a high match, it just returns the previously cached response. You're getting the answer for literal pennies instead of running a full, expensive generation.
And hey, if you're making highly structured, deterministic calls, meaning your temperature is set to 0 and the model is supposed to give the exact same answer every time, exact caching is a total no-brainer. You just hash the full prompt, check your database, and return it. It's incredibly fast and absolutely perfect for batch processing.
Okay, Section 4, Defending your budget through smart application design.
Moving beyond just caching, we have behavioral defenses, like model routing. Honestly, you absolutely do not need a $10 per million token model to tell a user what time the store closes. A 60-cent mini model, or something like Claude Haiku, handles that perfectly. By setting up a router to send the easy questions to the cheap models and saving the heavy hitters for complex reasoning, you can easily save 40 to 70% on your model costs. Next up, if your workload isn't real-time, you shouldn't be paying real-time prices. It's that simple. The OpenAI Batch API gives you a flat 50% bulk discount if you let them process requests asynchronously over 24 hours. For things like nightly document processing, bulk classification, or running evals, it's basically free money. Just, don't use it for real-time user chats.
And finally for this section, because a simple code bug or a malicious user can literally drain your bank account overnight, you absolutely must implement a circuit breaker. Set up these escalating kill switches. Warning alerts at 70% of your budget, throttling at 85% where you force downgrade everything to your cheapest models, and a hard stop at 95% where you reject new requests and only serve cached responses. This isn't just optimization, this is absolute survival.
Section 5. The Optimization Stack. Let's put this all into a singular roadmap.
When you consolidate all these individual weapons and stack these 7 layers in this specific order, magic happens. Each technique compounds on the previous one. First, let the provider cache your heavy system prompts. Then catch the exact repeats. Then catch the semantic paraphrases. For whatever actually slips through, route it to the cheapest capable model. Wrap the whole thing in rate limits, compress prompts where you can, and batch your background tasks.
Section 6. From burn to business. Let's look at the real-world savings.
Check out this triumphant math for that exact same 10,000 user chatbot we started with. By hitting a 52% cache hit rate and routing 65% of the remaining queries to a mini model, our total monthly cost plummets from $22.5 grand down to just over $5,000. That's a 76% savings. Latency drops massively too, and that minor $180 embedding cost for semantic caching, it literally pays for itself in the very first hour of operation. This right here is the difference between burning your runway and building a real sustainable business.
As we wrap up this explainer, I want to leave you with one final, absolutely critical question. Building a cool demo? That's the easy part. Engineering a system that actually scales economically is where your real competitive advantage lies. So, is your AI app built to survive the invoice? Take these 7 layers, implement them, and protect your margins. Thanks for joining me on this deep dive, and happy building.